Okay, this is our video solutions for Can You Do number 9. I am going to walk through number 1 with you, and then if so, pause. Okay, teacher, get a grip. So 1 and 2 are, I personally think they're a little bit challenging. So if you're struggling with 1 and 2, I'm going to walk you through number 1. And then I want you to try number 2 if you haven't done that already. So I'm going to walk you through 1, you try 2, and then the rest of these I think should have been fairly easy, and all you need to do is check answers. So the scores on Miss Martin's statistics test had a mean of 12 and a standard deviation of 3. Okay, so mean 12, standard deviation 3. Miss Martin wants to transform the scores to have a mean of 75, so 75, and a standard deviation of 12. What transformation should she apply to each test score? Okay, so I want to start with multiply and divide because both X bar and standard deviation are affected by multiply and divide. So multiply and divide affects every value. So let's start with S sub X, because adding and subtracting isn't going to affect standard deviation. Only multiply and divide will. So to transform, and I'm not expecting you to write all this, I'm just trying to make my reasoning clear. To transform 3 to 12. So notice we start at 3 and they want it to become 12. The only way that we can do that is multiplying by 4. So remember, we're starting with multiply and divide first. That's going to affect standard deviation, which means that to transform 3 to 12, we can't divide, we need to multiply. So we know 3 times 4 will give us 12. So the first part of your transformation is t equals 4x. T equals 4x. This is your observation. This was standard deviation. So you're going to multiply every observation by 4. Well, now what we need to do is transform our mean so that it equals 75. But here's the thing. You've already multiplied it by 4. You've already multiplied your mean by 4. So what we need to use is 4 times the current mean plus x needs to equal 75. So first transformation is multiply or divide. Now that we have that, how are we going to change all of the observations? And we're using, how do we get from 12 to 75? Okay, well this is 48 plus x equals 75. So x equals 27. And it's positive. So that means that our transformation is 4x plus 27. This is the mean. So now we can check our x bar of t should be 4 times 12 plus 27, and your standard deviation should be just 4 times 3. And that does work on both. I do not believe that I did a stellar job explaining that, so I apologize if this is confusing. But essentially, you want to start with multiply or divide because it affects every value. So I started with standard deviation because I know that standard deviation is affected by multiply or divide and not addition or subtraction. So that one just made the most sense to me. So then using that, I said, well, how do we get from 3 to 12? We multiply by 4. So the first part of our transformation is take every observation, multiply it by 4. Well, if you're doing that, then that means that you are multiplying the mean by 4. So that's what's happening here. The mean times 4 only gets you to 48. So how do we get from 48 to 75 by adding or subtracting? Well, you add 27. So find your multiply or divide first, then find your add or subtract. Okay, it is very similar on the next one. So figure out your multiply or divide first, and then figure out your add or subtract. Pause, because I'm about to go through it. Okay, Mr. Olson uses an unusual grading system in his class. After each test, he transforms the scores to have a mean of 0 and a standard deviation of 1. Mr. Olson then assigns a grade to each student based on the transformed score. On his most recent test, the class scores had a mean of 68 and a standard deviation of 15. What transformation should you apply? So we start with a mean of 68, and we want to change that to a mean of 0. Then you have a standard deviation of 15, and you want to change that to 1. So start with the multiply or divide, which means start here. In order to transform 15 to 1, your only option is to divide. You are going to divide by 15. 15 divided by 15 equals 1. So the first part of your transformation is t equals your observation divided by 15. How do I know where the x goes? Because this top number is s sub x. It's your standard deviation. So I'm going to replace that with an x because we're going to have to transform our standard deviation, our min, our max, all of our data values, our median, our range, everything gets divided by 15. Now we transform 68 to 0. But what we have to remember is that we have divided it by 15. So in order to transform 68 to 0, we can use the equation 68 divided by 15 plus a number has to equal 0. Okay, well, to solve that, I get x equals negative 68 over 15. So to put that all together, our transformation would be x over 15 minus 68 over 15. But I want you to notice those are common denominators, so what it actually is x minus 68 divided by 15. And then I want you to notice that this is the t-score. Mr. Olson, sorry, not the t-score, the z-score. Mr. Olson converted all of his students' scores to a z-score. The formula for that is right up here. Your observation, subtract your mean, divided by standard deviation gives you a z-score. So if you transform your entire data set so that it has a mean of 0 and a standard deviation of 1, you are finding, or you have a distribution of z-scores. That is the same as what you saw on our transforming page. Remember how at the very end I told you that what we had found was the z-scores? Notice that the mean was 0 and the standard deviation was 1. So this problem is trying to preview for you that if you have a distribution of z-scores, your mean will be 0 and your standard deviation will be 1. I think that those are the hardest to do. So if you have questions or you need me to Zoom me, let yourself know. Let me know. I tried my best to walk you through my reasoning, but I'm not sure if it's sufficient. Okay, on to the next. Number 3. Find the mean and median of the student's height. Find the standard deviation in the IQR if we convert it from inches to feet. So in order to convert from inches to feet, what we need to do is divide by 12. The conversion is divide by 12, which means that our mean and our median go to 577 and 579. Make sure that you have your units on there. Your standard deviation and IQR go to 0.26 feet and 0.79 feet. Remember, I could have these wrong. So if I've made a mistake, just email me and I don't know, I guess I'll send out an email and let you know that one of mine was wrong. Number 4, the school board wants to increase next year's salary by $1,000. So the transformation is take the salary, add 1,000. What will happen to the following values? Mean increases by 1,000. Median increases by 1,000. The extremes will increase by 100 and the quartiles will also increase by 100, but the standard deviation will stay the same. One quick reference to remind yourself why that is to look at this table. Everything here increased by 5 except for your spread values. So IQR, range, and standard deviation are not affected. The next section says they want to give everybody a 5% raise. So what that looks like in terms of a transformation is take everybody's salary and multiply it by 1.05. So the 1 represents the current salary and the 0.05 represents the increase. So if I currently make $60,000, then what my new salary would be is $60,000 times 1.05, I would get $63,000. Notice that if I just took 60,000 and found 5%, it would be 3,000. So this transformation just does does the adding or the end part for you. Like I could have said, okay, 5% of 60,000 is 3,000. Now add that into the salary. This is faster though. So the 1 represents the current salary, the 0.05 represents the raise. I did not write things specifically down for this section because I know that every value, when you multiply or divide, changes by a factor of whatever you multiply or divide by. So all of these values increase by a factor of 0.05. Actually, is that 1.05? No, 0.05. Because my salary increased by 3,000. So I'm going to write that down. My current salary is 60,000. My transformed salary is 63,000. So the increase was 3,000, and that is 5% of 60,000. So just the extra part on the end. Maybe I'm supposed to go, oh no, because they don't give you the amount, do they? Nope. Okay, last page. Find the mean and standard deviation of temperature readings in degrees Fahrenheit, and then it gives you the formula. So I got 77 degrees Fahrenheit for the mean, 3.6 degrees Fahrenheit for the standard deviation. If we need to correct measurements because we recorded them 0.2 inches too large, that means that we need to take every observation and subtract 0.2 inches. So the mean will be 3 inches. The standard deviation is 0.1 inches. What do I got going on down here? Oh, and then they want it in centimeters. Oh my heavens. Okay, so the first thing you had to do was correct the measurements. So that changed your mean to 3 inches and your standard deviation to 0.1 inches. Then they want you to transform that to centimeters, and the transformation's right here. T equals 2.54 times X. So mean becomes 7.62 centimeters, standard deviation becomes 0.254 centimeters. Then lastly, what is the distribution of tips? Well, if X is the cost of a meal, then his tip is 0.10 times the cost plus 2. So the mean of the tip will be $2.90. The standard deviation of the tip will be 30 cents. So the answer is alpha. Okay, so you will have a Canvas quiz on this whenever it says on your calendar. If you have questions, email me or you can Zoom me. You can also try your quiz and get the feedback and see if you're on the right track. This Can You Do is kind of short, so I would expect one of each kind. So I would expect one or two. Sorry, I'm just zooming out. And then a couple that are like 3 and 4. and then like one that's like these last pages. Okay, so I know that I don't know why, but I feel like this one was kind of a doozy. So hopefully you're feeling okay. Love you, Mooey. Hopefully see you soon. Well, you'll see me soon, but I hope to see you soon.